So in this lecture, we are going to talk about wireless protocol that a vast majority of devices around us use. And this is called Bluetooth. So Bluetooth is a low power protocol to enable wireless connectivity for device to device communication. And the focus is on making these devices to be as low power as possible. So a good example of Bluetooth protocol in use is our earphones. Like for example, Apple AirPod. They use Bluetooth to stream audio from the phone to the earphones. So what are the different layers for a Bluetooth protocol? So we can actually divide the Bluetooth protocol into different layers, and the radio RF and the physical layer is responsible for communication and for performing modulation. The link layer, it establishes and maintains and terminates connection between various Bluetooth devices, and it is also responsible for error correction and detection and for performing flow control. Next is HCI, which stands for Host Controller Interface, and it serves as an interface between lower layer and the upper layers of the stack. And the HCI layer also helps to abstract the hardware details from the software implementation. And thus it makes it very easy to develop and support Bluetooth application across different hardware platforms. Then L2 cap, it provides a logical channel multiplexing, segmentation, and reassembly, helping to support flow control and retransmission. And GATT is for discovering and reading various attributes on the remote devices. And this is something that we are going to talk about in one of the subsequent lectures. It is, of course, designed according to the needs of the application. So let's first talk about the two different communication modes for Bluetooth. So the two major communication mode are advertising and the connection oriented mode. So in advertising, it is used to send small amounts of data without establishing a connection with another device. And these are typically broadcast messages, and they're unidirectional communication that happens between a peripheral device and the scanner device. So the advertising mode uses Aloha as an access control mechanism. On the other hand, if you want to transmit that data bidirectionally and also ensure certain quality of service, as an example, if you want to stream audio and want to ensure that there is no lag and you can stream at the highest audio quality possible, you would use the connection mode of Bluetooth. And this mode is maintained for some duration of time, and it uses TDMA as an access control mechanism. So in this slide, we actually show the standard topology of a Bluetooth network. It consists of devices and their various roles. As an example, when the Bluetooth device is configured in the advertising mode, well, one of the central node acts like a scanner to receive transmissions from the peripheral nodes. On the other hand, when the node establishes a connection with the peripheral device, its role changes to a central, and then it is able to support bidirectional communication with the peripheral node. So one thing you should keep in mind that while supporting connection mode, the central device can also receive advertising message, and it can also be in connection with many other peripheral devices. So the topology is somewhat simplified view of roles of various devices in a Bluetooth network. Please keep in mind that the role assigned to these individual devices may change with time. For example, scanner node can instance act like a central node and be part of a connection with several peripheral mode. Also note that one peripheral device may be connected to multiple central nodes. So how does the frequency allocation for Bluetooth look like? Bluetooth operates on the 2.4 gigahertz frequency band, and there are 42 megahertz wide channels, and out of these, 3 channels are reserved for sending advertisements. And these channels are 37, 38, and 39. And while channel number from 0 to 36 are used for sending data in the connection mode, and it uses the frequency hopping spread spectrum to support high reliability. So what is the modulation scheme that is used in Bluetooth? It uses a variant of frequency shift keying. Thus, if you recall, the frequency of the carrier signal is changed according to the bit that we want to transmit. We show this with the figure that is presented on the slide, where the carrier signal has different frequency depending on the bit that we want to transmit. And in fact, Bluetooth uses a variant of frequency shift keying that applies a Gaussian filter, and it leads to the smoother transitions between the different frequency changes, and it allows it to reduce the interference. So how does the packet structure for Bluetooth look like? We show it on the slide. Do note that the access address for advertising packet is always set to this predefined value that we show on the slide. So Bluetooth also performs another operation which is called whitening. And this is important to avoid having a series of repeated bits in the transmission. And a sequence of steps are performed at the Bluetooth transmitter to reduce the number of repetitive bits in the data transmission. And it is in fact a great example of physical and MAC layer being interwoven in wireless communication. And the reason why you want to avoid repetitive bits is because of that it causes RF noise to be a bit more tolerable. So if you put it together, the bit processing pipeline for Bluetooth looks something similar to what we present on the slide. So you take the payload, you encrypt it, you generate CRC, perform whitening, and then you send it over the wireless medium. And then at the receiver side, you perform the reverse operation to get back the bits that were transmitted. So next, let's look at the advertising mode a bit more in detail. So advertising messages are part of the Bluetooth discovery mechanism, and it allows the nearby nodes to discover the advertiser's existence. While the traditional advertising messages has been used for discovery, however, it can also be used for general communication, as we will see with an example at the end of this particular lecture. And these advertisements are periodically sent, and the advertisement node packets are then received by another node which is in the scanner mode. So the advertising packets are contained into the PDU of the entire Bluetooth link layer packet. So advertising messages are, as we said, are sent periodically at a time period which can range from tens of milliseconds to few seconds or even longer. And typically these advertising packets are sent with some random delay. And this is important because this random delay is introduced to prevent two nodes from transmitting at the same time and causing a collision. And the application designers or user pick these values to trade off between energy and the discovery latency. Another thing to keep in mind is that since there are three advertising channels, we typically transmit these advertising packets on these three different channels in the same order. And after these advertising packets have sent, there is typically a very short listening video which can allow these nodes to receive any transmission. So how does it look at the scanner device? The scanner device reiterates through these various channels and listens for advertisements. And it typically listens at a very low duty cycle. And the reason is very straightforward: to conserve energy. And since we transmitted three different advertising channels, the scanning also happens at frequencies for three different advertising channels. So if you put all this together, the transmitter sends advertisements on three channels, and the scanner also scans periodically on these three channels. And when there is an intersection, that is, the transmitter sends at the channel, and the scanner is is configured on the same channel. That means that their sending and the receiving channels overlap. The successful reception of the advertising packet occurs. Hence, we need these advertising packets to overlap in both time and space and frequency for a successful reception. So advertisement are not only used for discovery, but it has also been used for communication. And we already have many commercial devices that are using Bluetooth advertisement for communication. As an example, for example, things such as a Tile or an Apple AirTag is using these Bluetooth advertisements to send location information as well as other information to devices that are nearby. They are also being used for sending, for example, small advertisements. Let's say you are in a retail store and you get these Bluetooth advertisements, which can contain marketing and other links that could then be used to sort of like send information about products in the retail store. And of course, tracking is also an important application where it could involve, for example, if you have a Tile or an Apple AirTag attached to objects and you want to keep track of their location. Many times Bluetooth advertisements are used, and you also use, for example, the receive signal strength of these Bluetooth advertisements to help you figure out the proximity of these devices to your phone. So with this, we can come to the end of this particular lecture.